Hello, welcome to this walkthrough of Lesson 1 for the Year 4 Coding for Climate Action unit of work, which is focused on data logging. The whole scheme of work for Year 4 is focused on data logging. My name's Matt Hewlett. I am the Community and Education Lead for Digital, and I'm really excited to be taking you through this lesson and all the other lessons, so let's just jump straight into it. First of all, to get to the resources, the best place to go is to our website. Hopefully you can see this on the screen that the web address is digital.charity, Coding for Climate Action 2025. Or you could just go to the website digital.charity and then choose Coding for Climate Action from the resource drop-down. That will bring you to this page. Now, if you're not aware, Coding for Climate Action is a series of units of work for Year 4, 5, 6, 7, and soon to be announced Year 8 as well, which focus on bringing together real-world scenarios, meaningful context, and the sort of programming side of the national curriculum in a method or a way, hopefully, that inspires teachers and students alike to realise the kind of real-world impact of learning computing, IT, and just how it can be so meaningful for them as something to do in schools, but of course, trying to think about how that could relate to life in the future, whether it's careers or otherwise. So hopefully you agree with all that. Let's have a look at how we get hold of the resources first of all. So once you're on this web page, if you scroll down a little bit, there's of course lots of details about the units of work, the core learning that's happening, some of the core kind of methodology behind the units of work. And on the right hand side, we've got a whole host of links that will take you right through to the units of work themselves. So we're looking at Year 4 data logging in. So I'll click on that right now. Please feel free to click along with me. That should open up a Google Drive, which has got all of the units of work for you to access for free. These are all free for you to use in your schools or other contexts, so please don't hesitate to get stuck in. As you can see from the Google Drive, we've got all the resources, all the lessons there. So it's a 6-lesson unit of work, all focused on using, like I say, the microbit, computing, and meaningful context, in which, in this case, coding for climate action, to sort of help develop and inspire young people. So we've got the lessons here for you, lessons 1 to 6. We'll have a look at those in a moment. But we've also got some wider resources and support materials as well, which you can grab hold of. So I'll show you a quick run through of all of these, but I won't linger on them too much. I know these videos can go on a little bit. So we've got, first of all, some additional guidance and overview of certain things you might want to have to support your teaching and delivery of this unit of work. So, for example, some additional details about how to use the microbit. If you've not used them before, hopefully that will be useful alongside these videos and lesson plans. And then some further details on about how we can just support students who might be thinking about the climate and the impact of the climate, and can of course have a bit of climate anxiety and concern about these sorts of things, which is not what we want to be leaving young people with. We want to have young people feeling empowered and inspired about what they can do to be part of the solution to the climate crisis. So there's some resources and thinking here if that's something that you think might be of value to you, or more importantly, I suppose, the young people in your charge. We have got a scheme of work overview, and again, I won't linger on this, but just so you know, that's something available to have a look at, all the lesson objectives, so we can see the progression of learning through the scheme of work, as well as how it relates to the national the national curriculum for computing. So please do take time to have a look at that as well. And then finally, the main other thing to focus on is that this is a data logging unit of work. So we have what's called a data logging journal. That's in a spreadsheet here, a Google Sheets spreadsheet. So I'll leave this one open because I'll be coming back to it as the kind of the lesson goes on, or this video goes on. But this is something that you'd want to distribute to each student, okay? Or maybe you could have students work in groups. That's up to you how you'd want to work with this. But if you distribute this spreadsheet to each student, there are questions in the PowerPoint that relate to each lesson. So we can see lesson 1, lesson 2, lesson 3, and so on. The idea being it is a pre-made spreadsheet. So when the students use their microbits to log data, they can then pull that data from the microbit and drop it straight into the spreadsheet, which is formatted to to produce charts and graphs for them, and has questions for them to follow, as well as we can see there's the actual links to the code that they need in the spreadsheet as well. So it's one of many ways we can disseminate the resources to students. And the last note on that as well is there's a exemplar spreadsheet for you to have a look at as well, with answers filled in and actual kind of data filled in as well from having run the programs before, so we can see what, examples of what the kind of final product of a student's data logging journal might look like. Hopefully this quick run through is bringing that to life a little bit. Cool. So let's have a look at lesson one. That's what we're here for. But maybe before I do that, so yeah, of course, it's a data logging unit of work. We've tied together the idea of microbit, the national curriculum, data logging, and the climate sort of crisis, and tried to come up with what we have come up with, a variety of scenarios and learning journeys which students can go through, where they learn about functionality of the microbit, they learn about reading and utilizing code, and they see how data logging in different scenarios can be used to help learn about the world around us, and therefore relate that to how we can try and have an impact or understanding of, and therefore an impact on, a positive impact on the sort of environment and world around us, with a view to thinking about how that might relate to the climate. So almost all of the lessons are kind of standalone lessons, although there is a narrative that runs through them in the form of Broadbeans, but that's to be looked at from lesson 2. So don't miss the lesson 2 video. Right, okay, so lesson 1, let's have a look. So there are 3 kind of well, in most of the folders there are 2 resources: the learning plan or teacher plan, learning guides, lesson plan, whatever we might want to call it. Teacher guide, there we go, that's what we've called it. And of course the actual PowerPoint that you can use to present the lesson to your students. So again, I won't go through the teacher guide, the lesson plan in fine detail. It's there for you to read. It is fairly detailed. Learning objectives, of course, there for you to use. Suggested time for the lesson, kind of snapshot of the lesson, how it relates to the national curriculum, some computational thinking points as well, if you want to think about how this relates to different computational thinking aspects. Materials you and the students will need with any links there, and some lesson prep as well. So for example, make students have got their data logging journal. Have you used microbit before? Here's how to kind of support yourself with microbit in different ways on different devices and machines if you've not used it before. So hopefully some good preparation for you there. And then, as we can see, the kind of run through of the lesson, nice and detailed. We just don't know who is going to be delivering the lessons, right? So some people might be microbit champions. They're super comfortable with using microbit. Some of you viewing this might have never used a microbit before. So we've tried to kind of think, well, never used a microbit before, or just feel somewhere in the middle, but feel more comfortable knowing there's as detailed lesson plan as possible. So we've tried to be as supportive as we can with the level of detail that we have, that we can offer to you guys. So run through the lesson plan there, but don't ever fail to get in touch if there's any questions that you have that this video or the lesson plan, etc., does not cover. So lesson 1 in and of itself, of course, we're trying to set up the sort of the series of lessons so the students can make the most of them, understand the kind of run through this idea, excuse me, of data logging, microbits, computational thinking, etc. So we're trying to, bring this up, and you can see in this, the learning objective, we're setting up the foundational sort of knowledge that students are going to need to continue with this unit of work. So what is data logging? What is data collection? What is input and output, being the sort of the core sort of computing fundamentals that we're exploring in this lesson as well. You'll notice that you might be viewing this video in like 5 years' time, in which case the slide probably won't be here. But if you're looking at this in 2025, which is what it is now, if you could have your students take this, and you could do this, the appropriate pre-unit survey, and at the end of the unit of work, the post survey, that would be really helpful. It's a free unit of work. We get funded. We've been funded by Amazon Future Engineer. Thank you, AFE, for funding this and making it available. But of course, we need to measure the impact and check that we're doing as good a job and it's as impactful as it can be. And you completing that survey and your students completing that really quick survey before and after is a really, really valuable way of us managing to capture that and hopefully produce more things for you to use for free. So I know time is limited, but if you have the ability to do the survey with the students, it would be greatly appreciated. All right. So as I've said, the lesson is kind of geared around introducing data logging and microbits and inputs and outputs. So the lesson starts with a few questions about what collecting some data and representing it in a graph. These aren't live graphs, so what you can do is go to the lesson 1 chart here and update the student data there and show, having asked these questions of the class, show the students the kind of the change in data. So we've got, 7 is too many people, cats. Let's say in our class we've got 3 people who like cats. And we've got 27 people who like dogs. That's much better. We can show the change in the graph and start interpreting how graphs change over time and things like that, or graphs change not over time but dependent on the data that's input to them, and start thinking about that relationship between the visual data we're getting and the numerical data that underpins the chart. And then think, of course, about how we can sort of make decisions or learn things based on that data. And in particular, in this case, which bits of data we've collected could help us measure environmental impact. Okay, so transport choice being the one. We know that lots of people drive. Can we have, could we theoretically say, have a walk to school drive, or not drive, a walk to school celebration, try and motivate people to do that. So trying to make a relationship between collecting data and actions that we can take as a result of collecting data. Okay, we're still thinking about data collection, though not data logging. So we then move students forward to thinking about data logging being collecting data over time, so we can identify patterns and trends. And then, of course, the whole idea being that we can make decisions and learn things about the world around us, which underpin the decisions we can make based on that sort of data logging and collection of data over time. So you can see here, we then sort of take students over to the lesson 1 unit, the lesson 1 sheet in the data logging journal. Have a look at this pre-populated chart and answer the questions and think about what we can learn from this. So hopefully, having thought about data over time, what data logging is, and how we can relate that to sort of impacts that we have, careers that we could have as a result of collecting data as well, which is a really important link we're trying to make with these units of work. That it's not just in isolation. There's a career or a bigger picture to what we're learning here. It relates to the real world. That could be careers if people were that way inclined, which is obviously what we're trying to encourage. Having developed that and set that up, of course, we need to introduce microbits. Hooray! One of the best devices ever made, if you ask me, and think about how we can use these as data logging tools, sense the world around them, collect data, and then start making decisions about impact we can have. So there's some content of this of the lesson is running through the kind of fundamental components of the microbit and what it does, and then importantly, bringing students around to this idea that like any computing system, it operates on the idea of sort of input, process, and output. We'll focus on inputs and outputs. Okay, so we've got a bit of code here that students can have a look at, a pre-written piece of code, and we can see there's different buttons being pressed. Things can happen when it shakes. So we've got different inputs, the things, the buttons pressed, or the directions, the commands that are given to the microbit, and the outputs, the icons or the sounds, or the kind of the scrolling letters going across. Okay, so trying to draw out that idea, that relationship between input command going into the microbit and output, what happens as a result of the input. So you can see here that if I copy that, we've got down in the speaker's notes, we have got the microbits code there. Okay. And of course, you might see we've got some sort of detail from the lesson plan there with the answers about what the inputs are, what the outputs are as well. So hopefully that's helpful for you. We can also see that code is in the lesson plan, and it is also in the data logging journal as well. So we've got that, trying to provided that in as many places as we possibly can. If I just shoot over to that, we can see it no longer works, which is really sucks. So let's see if I've got one that does work. Okay, that's good. Well, I'll go and fix the link in the in the data logging journal, but this one works. That's the main thing. By the time you've got these resources, all those links will be the same. So all of the code that we give to the students, to give to the students in the unit of work, is in this format. So there's a link to the MakeCode editor. We can see it here. It's pre-written code, and the students don't have to do any coding through this unit of work. Okay, so we're trying to reduce that cognitive load. It's all pre-written for them to read and download straight away and get working with the microbit, so they actually can use it straight away without having to worry about the code not working or not understanding code immediately, if there's that kind of obstacle. So all students can access this straight away. The ideal is that as teachers, we run through the code with students, we get them to identify certain aspects of the code, probe their understanding of it before they run it, and then after they've run it as well. Did they make a prediction about it? Was that prediction correct? What might happen if we change something here? If we change on button A press to on button B press, is that going to be problematic or not? Will it work? So we can explore kind of written code and without having to worry about them developing their ability to write code themselves. It's probably cognitively too challenging with what we're looking at, the code that we're looking at. In this form, right now, students can't access it. They can't do anything. They can simulate it and play it. So that's fantastic. So we can make predictions and we can have a look at what happens if we do different things. We can see that. But when we want to get to download the code ourselves, we can either download it straight away from this button here, or, click on Edit Code and shoot over here to the MakeCode, the full MakeCode editor, and then download it there. So I have my microbit. I'm going to quickly download this code so we can just see that in action. But there are, of course, lots of ways you can download the code. And you might know them already. You might be comfortable with this bit, but there, of course, if you're not following along with what I do right now, there are tutorials as well, links in the teaching guide and in the additional guidance as well. So I'm plugging my microbit in via the USB cable I have with it. I've got a nice green USB cable, and that's going to plug into the computer, and this is going to plug into the microbit. And then having plugged that in to the computer, there are a variety of ways I can download it, but the simplest way is just to connect and hope this works. And now I'm videoing it, something will go wrong, right? That's all plugged in, and I get a pop-up which you can't see, just saying, like, when you plug any USB or something like that, and it opens up like a folder. But I want to download, so I'm going to connect to my microbit already. Well, it's already connected. So normally, if it's not connected, you click on these three dots and then click on connect here. And then there's a series of steps you go through, pop-ups that you follow. Again, they're all on the microbit website. Once you follow those through, then your microbit is connected. So having done that, I click on download, and it will just transfer the code onto my microbit. And of course, because I'm filming this, it's going to take its time. The other way you can download your code to the microbit is to just download as a file, and then you can go to the downloads folder, and you'll see in the file explorer area where you've got your list of all your folders and devices that are plugged in, any USB sticks or things like that. You'll see you've got your downloads folder, but you also maybe further down have microbit in sort of drive D or E or something like that. It usually is. You don't need to open the microbit up like a USB stick. You can just go to the downloads folder and then find the file and drag. I made a loud noise and it set my microbit off. Drag the folder, the microbit file, sorry, that you want down into the microbit itself, and that will just automatically download it onto the microbit. Okay, it has downloaded. Let's have a look. Hopefully we can see this. So I made a loud noise. I've shaken it, so we've got it's got all of the outputs going. So I can make it a bit easier. There we go. That's my heart icon. There's a smiley face. A and B together. Get the duck. That's Quackers. If I shake it, we should get it saying ouch. And if I make a loud noise, there we go. I get some noise repeated. Fantastic. So cue lesson being derailed from all of that awesomeness, but hopefully it brings to life the idea that actually we can press buttons on a microbit to do things. We can make noises. We can shake it. So there's so many different ways we can have the microbit respond to different types of input. It can have letters, it can make noise itself, so on and so forth. So we're bringing in that idea of the input-output relationship. Okay. there we go. A download guide there as well in the PowerPoint for you. So the next few sort of slides are just reflecting on the inputs and what they are and how we can use them. Until we look at this next code here, which will be the data logging code. So we can see here, if I open this up, we can see I have got a program that when we press A and B, it will show the temperature. Okay, so we can now use this as something that's going to monitor temperature around the room. Okay, so students can, I'll very quickly just see if we can get this onto my mic a bit while we're talking. Students can use this to investigate the environment around them. I just downloaded that. Investigate the environment around them, find out what the different temperatures are around their classroom. All right, so there we go. That's nice and quick this time. So hopefully we can see we've got the square on, and if I press both buttons, we get, it is, what did that say? 21 degrees. Is that 21? Yes, 21 degrees. Okay, 20 degrees. Doesn't feel that warm in here, but there we go. The microbit, it's not a perfect device, but it's bringing alive these principles. Maybe I'm just too warm-blooded. Okay, so who can find the hottest or coldest spot in the classroom? What might affect the accuracy of our readings? How we're holding the microbit? Are we next to a radiator, sunshine, a cold spot? Where is the temperature sensor on here? Are we covering it up? Are we not covering it up? Things like that. So just to investigate the device and how we use it, as well as think, of course, about what inputs and outputs are happening. End of the lesson, reflection on the programming concepts we've used, and then thinking about, again, wrapping up that whole idea of data logging, how it can relate to climate action and how the rest of the unit of work will relate to data logging, microbits, computing, national curriculum, and climate action as well. Hopefully that is made sense to you guys. Thanks so much for enjoying, fingers crossed, this quick video. See you for lesson 2, and thanks again for being part of the Coding for Climate Action journey.